In this video, I'm going to finish up the two examples from topic 5, the first objective that we worked through, finding the inverse of a given function. In the previous video, we looked at the first example, I do, f of x equals negative 4x plus 3, and we found the inverse and graphed it on the website desmos.com, and we're going to do the same thing here. Instead of Desmos, you can use your calculator if need be, but I want to show you two more examples because now we're working with powers and radicals, all right? So the inverse of powers and radicals look a little bit different, but you should remember from Module 2, the inverse of a power is the root form of that. One more thing, after this video, I'm going to have you practice these on your own, and a piece of the practice is you're going to find the inverse of each function, but the number 2 says the graph on Desmos or your calculator to check your work to make sure that the image of the graph is definitely the inverse, meaning that it's symmetrical about the line y equals x, and we'll talk more about that. And then finally, you're going to state the y-intercept and x-intercept of the two functions, right? And notice the relationship between the two. So let's work through the next two examples, and I'll go through all those steps in this video. So number 3, I'm going to do down here on the left, and I'm also going to do number 1 on the bottom. So I'm going to follow step by step, just like we did for the first one. But if you notice, the first ones are linear, so they will look a little bit different. The first step in red is to switch f of x to y. Always do that if given the function notation f of x. So I'm going to write y equals negative 2x squared minus 2. That's just to get in more terms of switching now, because step 2 we have to switch the y's and the x's. We have to just put y in there instead of f of x. And step 2 states to switch the location or switch the spots of all the x's and the y's. And so I'm going to write x equals now negative 2y squared minus 2. And that thought process, you should always consider if the direction state find the inverse of a given function. The given function and the inverse of the given function, all of the x values and y values will be switched, all right? So that's why step 2 exists the way that it does in algebraically solving these things. Is all of the points or all the values on a graph or a table or whatever it might be of a function of x values would be the y values in the inverse. All right, step 3 then is to solve for y. This process is going to look a little bit different, and I wrote in step 3 that remember the inverse of a power is the root and vice versa. So that's what we're going to be working with right now. There's two things on the right-hand side that are paired with the y. There's a negative 2 being multiplied with it and a 2 being subtracted from it. And I have to kick out the furthest thing first, all right? So that means that the 2 being subtracted has to go. So in order to get rid of that, I have to add 2 to both sides, just like so. And now on the left-hand side, that x and 2 can't combine, so I'm just going to write both of them as is, x plus 2 equals, what's left is negative 2y squared. And then finally, my last step, that negative 2 is multiplying with the y, so I have to divide by negative 2. Cancel that out, and then divide by negative 2. All right? So finally, my y is almost by itself. I'm going to rewrite what I have right here. I have y squared equals x plus 2 over negative 2. Now, the x plus 2 over negative 2, you could rewrite it as y squared equals, both of these pieces can technically be divided by the negative 2. So this is a 1 out front, so this becomes negative 1/2 x, and then positive 2 divided by negative 2 becomes a negative 1. So either notation at this, or either way to write this at this point is perfectly fine. If you just want to write it like this and keep it simple, then you're more than welcome to. My final step, though, is this power needs to go away. In order to cancel out that power, I have to take the root version of that. So in this case, it's being squared, so I have to take the square root. If you notice, in your problem you're going to try, it's not being squared, it's being cubed. And so you would have to take the cube root eventually. But if I take the square root of one side, I have to take the square root of the other side. And so I'm left with then, I'll write it up here, y equals the square root of x plus 2 divided by negative 2. All of that exists underneath the radical. And that I've solved for y, so I've done step 3 as well. Now for step 4, to use the proper notation, I need to tell that this is the actual inverse. So f inverse of x, this is the inverse of the given function f of x, equals square root of x plus 2 over negative 2. At this point, I am done. Check. Same process. You could have squared or square rooted both of these sides, and then f inverse of x would have equaled that as well. It's the same thing. All right, so let's go ahead and check the original function's graph with our inverse function that we just found. All right. So to graph these, you can either open up Desmos in your web browser or use your graphing calculator. But I'm going to go to desmos.com, desmos.com, and then I'm going to click the button of Start Graphing. I'm going to input both the functions that we found and then see what the relationship is in relation to the line y equals x. So the first function, the given function, f of x equals negative 2x squared minus 2. So I'm going to put f of x equals, and I'm just using my keyboard to type this out, negative 2x. This a to the squared button would give me a power of 2 immediately. If ever you need to type something that's not the power of 2, you can use this a to the b button right here, because that'll give you the option to type whatever power you want up above. So I have negative 2x squared minus 2. I just scrolled over, or hit the arrow key to the right, and then put minus 2. That is my first function. Hit enter to go down to the next number 2 option for the next function, and I'm going to input what I wrote in purple here, the f inverse of x equals the square root of x plus 2 divided by negative 2. So I'm going to put g of x just to tell it that it's a different function. And then g of x equals the square root button's down here, square root of, it's a grouping of x minus x plus 2, x plus 2. So I have to put x plus 2 in parentheses because that entire thing is being divided by negative 2. And then to hit divided by, I hit that slash button behind or below the question mark, and then type negative 2 in. So there are my two functions, one in red and one in green. I have to compare it, so one more graph I want to put in, y equals x, about the line y equals x. And so at this point I've asked you as well to, in your homework, you're going to graph on Desmos to check your work and then find the y-intercept of one function and compare it to the x-intercept of the other. And so let's look at the y-intercept of the given function in red down here. The y-intercept is 0, negative 2, where 0 is the x value, negative 2 is the y value. In the function, in the inverse of the function, which we've called g of x, and it's in green, you'll notice that the values, the x and y values switch. So it was 0, negative 2, now it's negative 2, 0. And the relationship between that, you see the x and y values switch, but also the y-intercept of the given function becomes the x-intercept of the inverse function. That is another special relationship that exists between functions and their inverses. And vice versa. It might happen the other way, where x-intercept becomes the y-intercept. And so at this point, I would be done with the entire process that I want you to do for your homework. All right? So I'm going to go back and do one more example just to show you the algebra. I won't graph this one. And then I'm going to ask that you do both number 4 and number 6 on your own. So for the I do of this one, same first step, I'm going to switch out f of x with y. And it's the cube root of x minus 2 divided by 2. Now I switch the locations of the y and x. So now I have x equals the cube root of y minus 2 divided by 2. And then the third step, I start solving for y. Alright, so this process looks a little bit different because we're dealing with radicals. We have to take the inverse of the radical. So first step though, everything here is trapped underneath the radical. It's the cube root of all that stuff. So in order to get rid of a radical now, I've stated this in the step up here in red. Remember, the inverse of a power is the root, and vice versa. The inverse of a root is the same power. So we're taking the cube root, which means I have to raise it to the power of 3. Whatever I do to one side, I have to do to the other side. So now I have x cubed equals this 3, the power of 3 and the radical 3 cancel out. So this becomes free underneath that. Y minus 2 divided by 2. Now, I'm still trying to solve for y, so the next step, there's 2 pieces with the y on the right-hand side that you see. There's a 2 that's being divided by, or y is being divided by 2, and y is subtracting 2. And so I have to kick out the division this time first before I can get rid of the subtraction. So I'm going to multiply both sides by 2. So now I have 2 times x cubed becomes 2x cubed equals y minus 2. And I am almost done. One last thing. I have to add 2 to both sides. 2x cubed and that 2 cannot combine, so I just write both on one side. And now I'm going to put y on the left side to make it look a little prettier. Y equals 2x cubed plus 2. And the fourth step is to write it in inverse notation. F inverse of x equals 2x cubed plus 2. So if you were to graph this, the graph should show up and have the given function be symmetrical about the line y equals x with its inverse that we just found. Alright, so go ahead and try the next 2 examples on your own. Algebraically find the inverse of number 4 and number 6. And then I want you to graph number 4 and check your work. And so I'm going to show you how to do that in this video as well, just so you can compare those steps before you try all this on your own. So go ahead and pause the video and find algebraically the inverses of 4 and 6, and then graph number 4 in Desmos or your calculator to check your work. So please pause the video and try that. At this point, you should have paused the video and tried number 4 and number 6 on your own. So here's the steps for number 4. I circled step 1, step 2, step 3, and then finally step 4. And so for step 4, the f inverse of x equals the cube root of x plus 2 divided by 3. That is what you should have gotten. If you did not get that, please raise your hand so I can come check your work. And then down here for number 6, I laid out the steps in purple. Step 1, writing y instead of g of x, and switching the x's and y's for step 2, then starting to solve for y. This math looked a little bit different, but hopefully you're able to do it. I had to add 2 to both sides before I could start working with the fifth root. So finally, the inverse, g inverse of x equals x plus 2 raised to the 5th minus 2. And again, if you did not get that, please raise your hand so we can come check your work. Now, finally, I asked you to graph number 4. The given function and then the inverse function, alright? So I'm going to start doing that. I've graphed the given function, 3x cubed minus 2. Now the inverse function, I didn't necessarily tell you how to do this on Desmos. You have to find the cube root. If you see down here, there's the square root, but there is no cube root option that lays out initially. So you have to go into this function mode and then go to miscellaneous. And then this button here, n with the radical, means you can pick any root that you want. If I click that, so the first cursor says I want a 3 right there, then I'm going to hit the right arrow key to go down underneath the radical, and now my inverse function is the cube root of x plus 2 divided by 3. So in parentheses I need to put x plus 2 because it's grouped together, close the parentheses, and then divided by 3. Now let's look, because they needs to be symmetrical about the line y equals x. So this is what you should have gotten after you found the function and its inverse for number 4. The one thing I ask you to do is the y-intercept of the given function, which is in purple, exists right here. It's at 0, negative 2. Alright? Which means then the x-intercept of the inverse, which is this black graph here, should be negative 2, 0, which indeed it is. Negative 2, 0. So the x values and y values have switched, and the y-intercept has become the x-intercept for the inverse. If you need help with the graph part, please raise your hand so I can come talk with you.